Alrighty, let's kick off. Normal distribution. We obviously only went through the first couple of questions on those. I'm assuming you probably didn't get to finish the entire chapter in the whole less than a day you've had on it.
Yeah.
Did you spend any time on it?
No, I did. I looked at it
Hmm.
just for an hour today.
Oh, sure, yeah. Okay. Fair enough then. Cool. Whereabouts did you get up to?
After doing questions about, I'd just gotten towards the end of 16B.
Hmm. Yep. Okay. So let's see, 16B. Um, Oh wait, so did you redo these? Hang on, are you
Yeah,
saying what we did or?
it was like it was basically like what we did yesterday, but then obviously like we don't do all the questions, so it's like
Oh sure, so you went back and did the double ups on. Yeah, okay. Yeah, cool. Because we're only doing like part A or part whatever's of them. Yeah, sure. I get you. Um, Easy enough to get through the ones that you did.
yeah, could be.
Cool. Okay. We touched on some 16C stuff as well, taking us to. Yeah, I think we pretty much only caught up to like this block here of 5 to 11, those kinds of
Yeah.
percentiles questions.
The last question yesterday was question 5.
Oh, it was? Yeah, cool. Remember like scrolling down here, and some of these were chill, but we didn't do them just yet. Maybe we'll just hit question six, maybe 6 again, um, just so we can guarantee you remembered it, and we can move on from there. Very similar question.
0.67.
0.6. Okay, hang on, let me plot the
That's the
answers.
probability.
16C part 6.
67%.
You shouldn't be doing a percentage for question 6. The percentage, the probability is given to you, and you're looking for the Z value.
Yeah. All right. 0.67.
Yeah, okay, so 0.67 is the value. Let me just double check on the answers. 16C, question 6. Yeah, 0.67, that's it. So it's what you're finding is an x-axis value there, not a probability. That is effectively saying 0.67 standard deviations to the right would account
Yeah.
for 75% of the probability. Cool. That's pretty much all these except for these two. The only difference there is the direction of the inequality has changed. So we'll hit 10 just to see if
It
you remember how
has?
to
It's the same, no?
say that one more time.
Isn't that the same direction of inequality? I think question 8 and
Oh, these are the ones that
9
flipped.
are the flipped ones.
Oh, okay. Yes, sorry. I was looking here and then. Yeah, cool, you're right. So question 8 is where it flips. Yeah, we'll hit
Hmm.
that one.
1.64.
1.64 is close. Um, there's one little thing that you have to worry about when it comes to when the direction of the inequality is flipped. Did you put 0.95 in as your area?
First I put 0.05 and I got negative 1.64.
Yeah. Okay.
Then I put 0.95 and then it's 1.64.
So why did you feel like the negative was a bit of a bad answer?
Um, Actually not sure. I'm just
Hmm.
the negative could be wrong.
Okay. Well, let's think about what we found. What are the when you do the inverse norm? What do you actually get?
You're trying to find like sort of like a bound,
Yeah.
like
Yeah.
sound.
Basically, some sort of x bound. Yeah, you're right. Now, Z. What is Z all about in this context?
It's like a variable.
Yeah. Cool. In the context of normal distribution, why would we use z over any other letter variable?
Isn't it there's the equation to it.
Yeah, there's an equation to it. You're right. Yeah. Um, there's also this statement here: standard normal distribution. What's the difference between, or what do we know about the standard normal versus just any other normal distribution?
Standard normal is like it has to have a mean of 0 and a
Hmm.
standard deviation of 1.
Yeah, absolutely. So
Oh, so maybe it can be negative, that means.
yeah, okay, cool. It can be negative. That's the reason why. Yeah, anything left of the mean would be a negative value. So if we were to draw what that distribution would look like, it's always going to be a bell curve, yes, but 0 is dead center. So you could have positive 1 over there, negative 1 over here, and so on and so forth. So when you get your negative value, the negative 1.6-ish, put that there maybe, 1.6, and because it was greater than, it's all of this area there. It was greater than, right? Yeah. There we go. Yeah, that's pretty much what's going on there. Makes enough sense?
Yeah.
A lot more unlikely for regular normal because usually we're measuring quantities and a lot of quantities can't go negative, right? You're not going to have negative lengths, negative areas. There are some things that can go negative, but they're few and far between.
But is Z like just the amount of standard deviations or?
Yes, that's the easiest way to think about it, which is purely and simply Z is just talking about your x-axis purely in terms of standard deviations.
Okay.
Yeah, that's the easy way to think about it. That's what those questions are like. Basically, you're just changing what the area is going to be considered 1 minus the thing if you're pointing right, or just what it was if it's pointing left. Question 12 is just a complete repeat of other stuff, just with the regular normal, mean, standard deviation, find target probability. I'm sure
Wait,
you...
and the D part of that, the one that has two parts,
Yeah?
is there a slight catch to it, or is it just
Uh,
two internormals?
well, this whole thing is CAS related, so if you check your normal CDF, you get to put in a lower and an upper bound. There's no real trick there, no.
Okay.
If it was tech free, maybe you'd have to start considering, okay, well, it's 1 standard deviation left, 2 standard deviations right. I'm just rounding there. And then you have to use your approximations to figure out that overall area. But because it's CAS, you're allowed to plug in the upper and lower bound just as given.
Right.
Yeah, so if anything, that's more straightforward because these ones, I don't know, some people get a bit weird about putting infinities in the normal distribution.
So these like all just normal CDFs.
Yeah, anytime you're trying to find PR something, it's always a CDF for normal anyway.
So say like the one like part C, right? It's probability X is more than 110.
Hmm.
Then would your lower bound have to be 110?
Yeah, lower bound 110.
How do you get like infinity in the CAS? I don't know like how to find it.
Oh yeah, it's on the pi button. It's on this.
Ah, okay. Cool.
Yeah, so 2 over. And you'll also be interested in the I there pretty soon for Spash. The complex
Imaginary
numbers.
number.
Yeah.
Uh,
In fact, yeah, we might as well. Well, while we're on that point, if you go to your settings, you're going to be working a lot in rectangular, I imagine. So probably just make sure you're in rectangular there.
Vector format.
Yeah. Actually, hang on. Yeah, okay. Must have been in the real or complex setting there. There's a difference between rectangular ways to express complex numbers and polar version. A lot of what you do is going to be rectangular. But maybe you just leave that. I can't imagine having rectangular is going to be an issue versus having real. Who knows? I'll put it in there and I'll see if we get anything weird.
Right.
I'd be shocked though, because everything we do should have a 0 imaginary component. Anyway. Yeah, question 13, same deal. PR something for normal is always CDF. It's only when the probabilities are given to you that you then move on to your inverse normal, which is what we have here. So let's see, 14. Mean is 6, standard deviation is 2. Find C such that this is true. We've done one of these before. Well, it's... No, actually, no, we did these over here. Yeah, it's the same thing, but instead of Z, it's X.
Yeah, and also there's like different. It's not a normal. It's not standard
Yeah,
standard normal distribution.
yeah, correct. Because now you got to use these statistics. Oh, these are... Yeah, no, those are statistics. You've got to use those in the CAS instead. These are the same. These are slightly different because now you've got an upper and a lower that you're trying to find. But it does also mention the approximate rules. I'm sure you could probably assume what each of these are going to be, just based on the... Well, actually, does it say... Well, it does say 2 decimal places, so I guess it is trying to get you to CAS it out. So this will be different than just approximating. Yeah. Try to CAS this out. This is where it gets a bit trickier. This is what the other CAS would use the center option for, because it can, in its inverse normal, it can pick whether left or right. But it can also pick center, which is when you would use this sort of thing.
No, I'm not really sure how to solve this one.
Not sure. Okay. Was there anything you tried?
Yeah, thought of normal CDF, but
Yeah, okay.
no,
Something like
there's
a
no
normal CDF.
there's no like, information on like standard deviation or mean.
Yeah, there is. Z is the standard normal.
Oh, it is standard normal.
Yeah, so it told Z here, and so you can see the capital Z will always mean the standard normal, but it also says it in the question as well. Yeah, maybe head back there now that you know that.
Okay, is A gonna be actually hold on. Is A gonna be 0.47?
0.47 is quite low there. Let me think. If you double that, 1.7, doubling it gets you closer. So how do you get 0.47?
Honestly, just a Hail Mary. Just put it in normal 0.680 and 1, and I don't know that's right.
0.680 So where do you put... Oh, was this the inverse normal?
Yes, correct.
Okay, cool. So what you did there was as follows. You told the CAS to figure out what value of A accounts for 0.68% going left. Whereas what we actually want to have happen is what upper and lower, A and negative A, account for 68%. So you've got more or less all of this bit that's included when you don't want it.
Oh, so okay, hold on. I've got an idea real quick.
Yeah, shoot.
Um, Let me know if this is right or not.
Mm-hmm.
So the positive A value will be 0.994,
Yeah, there you
and
go.
then the other value should be, oh, hold on, negative 0.994.
Correct. Yeah, precisely. Um, did you just like figure out? Actually, no. What did you do from there?
Inverse normal 0.84, 0, and 1. There's a 68% confidence interval.
It's normal 0.84.
And then I did 0.16 on the next one to find the lower bound.
Oh yes. Okay. Yeah, I gotcha. Right, because you figured out what's all the way left, and then yeah, flipped it. No, that's cool.
But
Um,
then I guess I could just use like, well, symmetry for that. And also because it's going to be,
yeah. Once you've got one of them, especially because both values are A and minus A. Once you know one of them, obviously the other one is, well, it's just going to be the negative of the other. Yeah, no, that's basically what you do there, which is you do some sort of funkiness to either figure out what's everything left or do everything left anyway and then just cut out the bit that you didn't want to have happen. Um, those would be the two main ways of going about it. Both are perfectly fine. Nice. Um, B and C are the exact same thing with different confidence intervals. If you want to practice again, you can, but I think there might be. Yeah, 17 is slightly different. You're still doing a similar thing, but it's not standard normal anymore. So A, B, C is also a bit different. You're doing conditional there. Maybe before we hop into D, E, F, we'll have a look at C here. See how conditional probability works with normal.
okay. I think I have a slight idea what to do here.
Good.
Um, it's going to be 0.52.
0.52. Yeah. Um, technically, tell. Actually, no, it doesn't say rounding at all. It said rounding up here, but nowhere here. Yeah, that's fine. They're just in the book it out at 4 decimal places, but they did not specify that at all. Here in the actual textbook. Nice. Yeah, just conditional probability there. Intersection over conditional. Nice. Part D is the easier version of what we did. That was like these ones.
Yeah.
And E is also that. It's more so F that's kind of like this, but normal instead of standard normal. Maybe try that with F.
All right, I got C1 to be 8.28 and
Mm-hmm.
C2 to be 35.72.
Crushed it. Yeah, well done. Did you use the symmetry thing after you had the first one, or just solve both?
No, I don't think you can use symmetry on this. Oh, well, actually, can you? Well, no, I didn't really use symmetry.
Hmm. Yeah. How would you be able to use symmetry in this case if you had to?
35 minus 22, and then
Yeah.
just subtract whatever you get that from 22 again.
Yeah, it's the you're finding the difference. That's the distance from left to right, and then just go the other direction. Yeah. Cool. I think that's about it. Is this just another copy? Probability, conditional, basic percentile, and double bounded percentile. Yeah, that's another duplicate. Sweet. Let's see. What's 16D? Is that when they're starting to, yeah, starting to give some background information, but they still use the word normally distributed. Normally distributed. They still talk about the mean and standard deviation of the thing. So it should be more so than anything else, any other probability type, fairly obvious what things are, like what goes where. Like mean is always the mean, standard deviation is always a standard deviation. So when they mention things in terms of like seconds, well, it doesn't really matter what they say, it's measured in terms of, we know it's x-axis related stuff. Um, limits of acceptability, that's the whole. Yeah, actually, we'll talk about this one just because. So this is, I believe, more or less the last couple of questions we did with the double bounded inequalities, but they put a lot of wording around it. So in this case, we're manufacturing metal rods, and they are acceptable as long as they are within this tolerance. I'm assuming we're supposed to make them 2 meters, but we are 2 centimeters rather, but we have this sort of tolerance either side. 5% are typically undersized, and 5% are typically oversized. So oversized meaning above this, undersized meaning below this. Assuming this is a normal distribution type, assuming like the lengths here are normally distributed, we're told to figure out the mean and standard deviation. Okay, maybe not so much what I was thinking initially. So trying to find the mean and standard deviation, well, the only equation we have when it comes to normal distribution is the z equation. So you'll notice the z type thing going on here. Z is equal to x minus the mean over standard deviation. When you're trying to find two things, you need two equations. So in other words, we're trying to figure out the two equations that we have and then simultaneously solve, more or less. The two equations are going to come from here, right? When you have yeah, how do we know that we're looking for probability stuff rather than z stuff? Because when you think about having like a mean and standard deviation in the z formula, typically what you're looking to do is solve the x and the z in two separate instances, and that'll get you the two variables with two separate equations. So I guess knowing that you're trying to solve for x or z or both, there's only really one way you can do that, which is through the inverse normal. And so that would probably be the first thing you think about, which is, okay, I need to get my x and z's. Based off of that, where am I going to get my inverse normal related stuff? And that's going to be from here. These 5% rejected as undersized or oversized. That gives you these two probability equations. This one being oversized because you're greater than the tolerance, and this one being undersized because you're less than the tolerance. Fair enough so far how we've gotten to here?
Yeah.
Cool. This one didn't actually, now that I'm looking at it, didn't really even use a simultaneous. It just sort of knew, hey, if this is your bounds of tolerance, then the middle is going to be 2. Like that's just the mean. Um, I wonder how. Yeah, I guess you can make that assumption. I can imagine maybe in some circumstances you wouldn't want to assume that it's symmetrical either side of the mean. There's nothing in here that inherently tells you these bounds are supposed to be centered at the mean. But yeah, I guess in this case it's fine to use that, but you'd probably want to default to a simultaneous, which will still give you the same result anyway. But okay, what do you then do from there? Well, it would just be two separate inverse normals on the CAS. So assuming we're not going to use this little cheat of knowing the mean already, you would do two separate inverse normals. One with, so the undersize, because it is pointing left, you would keep that as 0.05 with the standard normal. And the other, because it's pointing right, you'd make that 0.95 with the standard normal. That would get you two separate Z values that you're working with. And then these are their corresponding X's. It is a bit of a different thing they've used here. They've actually done them both anyway, even though they didn't really need it because they've already got the mean. So one of them was going to give you this, the other was going to give you that, and yeah, simultaneously solve those. So yeah, they've actually gone ahead and done that as well. They said, hey, even if you didn't recognize the mean would be 2 from the symmetry, you can do the simultaneous there. Fair enough.
Yeah.
Yeah, let's see. Suppose that IQ scores are normally distributed with that and that. What is the probability of these? Okay, so these are just worded versions of finding probabilities. I think maybe it'll be good for you to have a read through any of these and see if there's anything that looks like it's tougher. Because it's harder for me to put myself in your shoes as like what looks different than what you've seen before. Because I have made it worded, but fundamentally, I believe a lot of these are going to be the same actual math as what you've done in the previous chapter. So I guess I'm curious to see which of these look different. If any.
I mean, I guess can we just start with like question one and then like slowly we can like
Yeah, yeah, by all means.
build up.
So, question one, we're given the mean and standard deviation of the IQ scores. What is the probability a person chosen at random has an IQ of greater than 110?
Okay. Is it 0.25?
0.25. Yeah, precisely. You're looking for a probability, and the only way you ever do probabilities is the CDF with the mean and standard deviation that are given. Um,
I'll do triple I.
yep, triple I, sure.
0.36.
0.36 is a little bit big there. What was your method there?
Intersection and over probability of
Hmm.
110.
Yeah, greater than 110, sure. What was your intersection?
Like 0.09.
Okay, 0.09 is a bit off. What was the actual like probability statement for the intersection? What did you simplify it down to for boundaries?
As in like normal CDFs.
Yeah, like what was your upper and lower for the intersection?
130 to infinity.
Okay, well that should have been right.
Oh, I think I see what I've done here. Okay. Let me try that once more.
Yeah, okay.
So is the official answer 0.09?
0.09, yeah, that's it.
Yeah, that's you.
Cool. I'm assuming just some CAS weird, maybe typo or something.
I calculated my intersection the wrong way.
Yeah, okay. Cool. But yeah, you knew it was conditional. You knew the idea of what you were supposed to do, but you just typed in something different. That's cool. Part B's got some wording around it. To be allowed to join an elite club, you must have an IQ of top 5%. What IQ score would be necessary to join the club? That's funny.
Let us see. Is it 125?
Yeah, yeah, around to 125 there. Yeah, nice. Awesome. Question 2 is looking to be worded very similarly.
Yeah.
Same with question 3. Maybe I'll just, yeah, tallest 10, shortest 20. Maybe if you can briefly talk about the difference between tallest 10 versus shortest 20. What changes between those two questions?
Um, so what you can do for tallest 10 is you can do inverse normal
Mhm.
with your area as 0.9,
Yeah, that's good.
which will help you find, which will like find you the X value.
Mhm.
And for shortest 20, you can just do 0.2.
Yeah, that's it.
Because it's arc has resorts to whatever's left of the value.
Exactly right. Yeah. So understanding that tallest means you're in the upper end and it's to the right, shortest meaning to the left. Yeah, so I can't add adding that. Very good. These same again. Top 15% is distinction. Yeah, okay. So again, same thing. Greater than that, between that and that. Percentage probability. So these are just telling you the boundaries of your CDF. Here we go. Find mean and standard deviation. That's like the example we started with.
Okay. Okay. I got a mean of 1.26.
Seems a bit small. What was your standard deviation?
0.6.
Yeah, okay. Something's a bit off there. Maybe, or the answers are off. One of the two. Um, okay, cool. Let's suss that out. What was the first thing you did?
Um, Make equations
Yep.
for things.
So what were they?
1.8 minus the mean all over standard deviation is equal to 0.9.
0.9. Um, oh, okay. So off the bat here, this 0.9.
Should be a 0.1.
No, no. What you've done is you've equated a percentage to z, because the equation that this is z equals x minus mean over standard deviation. You just put a percentage in the z spot. So that's all that went wrong there. So in reality, what you want to have here is z, and you want to figure out what z corresponds to this x of 1.8. And you want to do the exact same thing with the other equation, which is you also then have, so this is equation 1, you then also have z is equal to, and we'll call these z1, z2, just to be clear, those are different values. Whoops, hang on, this is blurry. Yeah. The other x was 1.35, and then we're doing that mean over standard deviation. So this boils it down to now we have to try and figure out these z's. What do you think we do from here to find a z?
Um, I mean, we've got three variables, right? So
Mm-hmm.
I guess we have to eliminate some to find others and then make it into equation with only one unknown variable.
Yeah, so normally when we're doing our algebra simultaneous equation type stuff, we're looking purely within these equations and trying to do our algebra from there. There is more information that we haven't actually put down here that belongs in question 5. What information is not present in these equations?
In question 5. I mean, the whole of the second sentence is in the equations.
Yeah.
The third
Oh, well,
sentence,
no, it's not actually.
no?
This is the second sentence. Third sentence is all in there. We got mean and standard deviation in our equations. Some of these numbers aren't in there.
Is that going to be the Z's?
It's going to be related to helping us get the z's, but percentages, there's nowhere in this equation which has the 10 and 15%. Because they don't belong in z equations, right? Those are probabilities, whereas z only ever has, well, z, x, mean and standard deviation. So what that's telling us is there's some more information that can help us get, even if you don't know exactly where it's going to go, it's just more information that can help us get something. So if we were to create equations that now reflect these percentages and put those into equations, what kinds of things would you write? Like, for instance, just this statement here, 10% of cats weigh more than 1.8. How would you write that down?
No, I'm not really sure.
Okay. When we think of percentages, we think of probabilities. if we were to write this as a probability statement, does that help? What
Like
kind?
probability of cat being more than 1.8 kilos is 0.1.
Yes, that's it. So we have this statement now. Probability of x being greater than 1.8 is equal to 0.1. It then follows the next one would therefore be what?
Probability of x being less than 1.35 is 0.15.
So this is the information that wasn't present in our z stuff. And if we look at our equations and think, okay, we're definitely not going to get the mean and standard deviation from this, otherwise, well, we wouldn't need the simultaneous. So it's likely that this sort of stuff can help us get z. That's the sort of context clues I would be looking for, anyway. What could we potentially do with this information to help us get z?
Maybe something like a wait, actually hold on. I was gonna say like a CAS function, but I don't think it's gonna work here.
Well, you'd be correct to suggest a CAS function. Yeah.
Um, Normal CDF.
CDF will be not quite the CAS we're looking for because CDF is for calculating probabilities. We know the probabilities already. The inverse normal is the only other one that you could choose, and we effectively use that for everything else, right? Whether it's z, mean, standard deviation, x, any of those things, we use the inverse normal for. To put it in a bit more
How can
perspective.
we like use inverse normal if we don't know the standard deviation or the mean?
Yeah, okay. So what I'll do is one thing that's worth pointing out, whenever you have this sort of stuff going on, technically whenever you have a normal distribution anyway, there's always an equivalent way to get to the standard normal. And the standard normal is super useful because of a couple of key properties about it. What are the key properties of standard normal?
So we're gonna have a fixed mean and standard deviation of 0 and 1.
Yeah, that's it. And so if we know guaranteed the mean is 0, standard deviation is 1, in our inverse normal, that only leaves one thing left to find, or to plug in, which is the area. And, well, when we think about the equivalence between regular normal and standard normal, if I draw the first one, for instance, greater than 1.8 would be 0.1, so that would mean 1.8 would be like here-ish. I'm assuming that's going to be roughly 10% of the area. This would be the x version, so you'd have some sort of mean like that. If you then superimpose that, this is supposed to be the same picture, but bear with me. Superimpose that on the standard normal, we now just have a z, which is there, with the exact same area. And so yeah, all we're going to do is say, cool, how do I plug this version into my inverse normal? With that in mind, what do you think we're going to plug in for inverse normal?
0.1,
Well, 0.1 would be to the right.
0.9.
0.9, yeah, that's it. So if we go 0.9, oops, not like that. We're going to get what we're looking for there, which is the equivalent z value that corresponds to the x that we were looking for. We'll do the exact same thing for the second equation. So this one is x less than 1.35. Good thing about standard normal, doesn't matter how many equations you deal with it, it's always going to be mean of 0, standard deviation of 1. So the only question we have to ask ourselves is, what's the area for this one going to be?
That ain't real big. Okay, when I put into inverse normal like a negative,
Yeah, negative is a good number.
Negative 1.04.
Yeah, round it to negative 1.04, that's it. And I mean, we should think that makes enough sense because x being less than 1.35 being 0.15, you'd be basically saying, maybe over here-ish, 1.35, and then we'll say this is 15%. Since that's left of mean, well, there should be a negative z value that corresponds to that. So that's a bit of like how you can error check and make sure that things aren't going weird.
Yeah.
Point is, we just found our z's. So this first z, that was using the 1.8, which was the first one we did. So that's going to be 1.28 here. And the second z we just found, that was negative 1.04-ish. This is now just a simultaneous. I'm sure you know where we go from here.
Yes, I am putting into the CAS right now.
Nice.
Mean is going to be 1.55,
Yep,
and standard deviation is going to be 0.19.
that's it. Yeah, precisely. Cool. So overall, whenever you're trying to find mean, standard deviation, any of the statistics, even any x or z, the inverse normal is going to be important at some point in the question. Even for something as simple as you've got x, z, mean, and you want to find standard deviation. Well, I guess, sorry, in that case, you're just going straight to z formula anyway. But very likely, you'll have something like this, which is you want to find both. And under those circumstances, inverse normal is always going to be important. You just need to be able to set up your z equations and the equivalent probability equations. So I guess as far as the logic tree you would follow here, you see it says find mean and standard deviation. We know inverse normal and z stuff is going to be important, so we get the z stuff down. From there, we see the probability statements, so we write those down, and our understanding of the inverse normal then comes into play, which is we work with the probability statements there to get our z's, and well, then it's just simultaneous from there. That's the kind of logic tree. What's going on here? Question 6. Normally distributed, mean 48, standard deviation 15, passing is 53. How many passed percentage-wise? Yeah, okay. That's probably not much different to what you're used to. 8% gained an A by scoring some value. What was that value? These also look similar to what you've done before. I'm curious if you feel the same way.
Yeah, let's see. 37%.
Yep, 37% for the first one.
$69 marks.
Yeah, correct. 69 marks. Nice. Probability of being greater than 190. Probability of 2 people being. Oh, okay. Yeah, here we go. That's some fun stuff. Oh, they're throwing these in there already. That's cool. I'm not gonna give too much away for this. 7B. I wanna see how you think about it first.
I don't. No worries.
It's very rare for a chapter question, but very common for an exam question.
17A, I got 0.02,
0.02, yeah.
and for B, what the hell? My CAS is doing some funny stuff, but I'm gonna say it's 0.02 squared
0.02 squared. Um, is it going to be 0.02 squared? It's possible.
because tree diagram approach. That's what I'm thinking right now.
Yeah, yeah, basically. Oh, hang on. Is it going to be tree diagram? How do you tree diagram that? You do either yes or no. Yeah, yeah, it's tree diagram approach.
Yeah, I was like, it should be 1 on 2,500, but my CAS keeps on giving me some like, the E.
Oh, sure. Yeah, yeah. Okay, I get you. Yeah, it'll end up being that. You're right. 0.0228 squared. Oh, yeah. No, I see what it is. Um, yeah, so e minus 4 just means you've got 0 point trip 0 and then 5. So basically whatever this number is, you do one less as the number of zeros. So 0.123, and then whatever's left over goes there. So you can see how that truncated it to 5e minus 4. That's how that's scientific. Is it scientific notation? I think that's what it's
Just
called.
didn't feel like scientific notation, but
Yeah.
isn't scientific notation like times 10 to the power of anything?
Yeah, that's right. Yeah, scientific is times 10. I wonder what. I think E is just a CAS replacement for times 10 to the power of -4. Also,
Okay.
yeah, I think that's what. Yeah, you can't quite.
Oh, anyways.
Yeah, okay. Anyway, that's what they mean by that. But yeah, um, that ended up working, which was because you're finding two successes effectively here. Um, it's just there's only one outcome on the branches. Yes, you could do a tree diagram approach, but when you have a look at part C here, for instance, 10 males selected at random, probability of at least two, having heights above 190. Now you're running into issues with the tree diagram, which doable, but you wouldn't want to do it. I gave a bit of a hint there with my phrasing. What do we have to do to um, reapproach the scenario?
Gonna be the one where it's that equation where the order doesn't matter.
Yeah, yeah.
Um, I want to say permutations, but it might be selections.
Oh, okay. Yeah, that's the yeah. So that equation you're thinking of is the selections equation. Yeah. Um, we'd be using the Bernoulli sequence for this sort of thing, which has that in it. It's binomial here,
Right. Yeah.
which is we've got n is 10. We're using 10 trials, 10 males, at least two successes, where success is considered to have a height of greater than 190. Where's the p-value going to come from?
He is. Wait, let me just look over my notes real quick. Is the probability of success, so that's going to be like 0.02.
Yeah, the 0.02, correct. So the fun thing here, very rare for a textbook question to do this, where it transfers from previous topics like that. But this is like the bread and butter of what you get in the exam, which is they'll start with one probability and then they'll change it up to a new probability type in the exam, and they may or may not use the outcomes from one thing to fill in the blanks of the other type of probability,
Yeah.
which you've spotted here. This normal CDF was able to get us the P for binomial, and then, well, this case is just binomial CDF for 2 to 10.
Yeah.
That's,
Let me try and
yeah, go for it.
um do that.
Um, you might find that you want to put in a dummy variable for P, or just like whatever value, and then just cut and paste in the other one afterwards, depending on speed, I guess, just so you don't put too many decimal place errors.
Is this also 0.02?
Yeah, roughly 0.02. It'll be.
0.019, then like
Did
around
you
to
put a
0.02.
rounded version of the CD of the previous answer for P?
Yeah, I round to 4 decimal places.
Yeah. So I mean that's why we typically don't round it, because in the book it's supposed to be 0.0206. Obviously, I didn't specify how many decimal places in the actual question, so you can give whatever you want. But in reality, in like an exam, sometimes I'll say up to 4. And if you are using a rounded P to 4, that's when you start getting rounding errors. Which is why I was sort of pointing towards when you're actually using the setup, right? When you go and do your binomial CDF, you're looking at doing, okay, you got your 10, you got your P value, but you don't want to put in a billion digits here, so you just put in some dummy
Ooh.
whatever.
Just
To
remember that function existed. I literally used
Oh,
I literally fully inputted the Bernoulli sequence.
oh, really?
Yes.
Wait, so did you do at least one minus then?
Yes.
Okay, nice, cool. Okay, yeah, definitely CDF, definitely CDF. Um, and then yeah, you would take the value that we had before, which was greater than 190. So you do 190 to infinity. The mean was 176. Standard deviation 7. And then that way, when you come and do to fix this up, you can just grab a copy of it and put the whole thing in there and not have that rounding error anymore.
If you defined like that 0.0227 as like a variable, could you put that into the CDF or no?
Yeah, I wouldn't go that far though. I would just Control C on this, and then I'm pretty sure Control C, Control V carries through. Let's find out. Yeah, probably just Control C, Control V it. Defining is going to take a few more clicks. But yeah, defining should also work as well. So
Yeah, because knowing me that like method of delayed gratification, I'd probably forget to do it.
sure. So yeah, let's see if we define that as A. That's not going bold, but it also is a different text editor. Yeah, it's fine. It'll be bold when we grab a copy here. Yeah, that works fine as well. Defining. Cool. Okay. Yeah, that's about it for this one then. So there's a bunch more questions for you to practice there, should you be inclined to. They are all very similar. I'd imagine maybe if you want to keep similar level of difficulty, just continue on from question Yeah, 7. Otherwise, just go in reverse order until satisfied.
Cool. How did you find the resources I sent you yesterday?
Yeah, I didn't spend too much time looking through all of them, but it's I could see the headings at least, and there was all a lot of it was there, which is good.
Yeah. Cool.
Yeah, I had a look at some of the what were they called again?
Contour.
Contour. Yeah, I saw their worksheets. I think was there. I don't know if they had any like actual textbook or teaching related stuff. I thought it was more worksheets in there, but that was only a brief scan through. Um, but yeah, I'll continue to suss it out.
Cool. Thank you very much.
No worries. Take care.